In this example, we're going to look at how to apply hypothesis testing, in particular the one-tail hypothesis test. So the question reads, John tosses a coin 8 times and it comes up heads 6 times. He claims the coin is biased towards heads, with a significance level of 5% test his claim. So first of all, let's write down what our test statistic is. So we're going to say let x, the random variable x, represent the number of heads that come up. Now, on a fair coin, the probability of getting a head is a half, and not getting a head is also a half. So we have 2 outcomes, getting a head or not getting a head. Each trial or each flip of the coin is independent of each other, and the probability of getting a head each time is fixed at 1/2. So we can then say that x can be represented by a binomial distribution where n is the number of trials. So we have 8 trials since we're flipping the coin 8 times, and the probability of getting a head is 1/2, which is the probability of success. We can then go and write down what the null hypothesis is. The null hypothesis is what is expected to be the current probability, the norm. Now, for a fair coin, we expect head to come up, the probability of head to be a half. So we can say here p is equal to a half is the null hypothesis. The alternative hypothesis is what we are testing. So the claim here is that the coin is biased towards heads, which means we expect head to have a greater probability than a half. So we will write this down. Probability is greater than a half is the alternative hypothesis. Now we are going to then write down the possible outcomes that we could have if we flip this coin 8 times. So x, which is the number of heads that come up, could either be from 0 all the way up to it could come up 8 times. Now, since we are looking at testing if the coin is biased towards head, we are looking at probability being greater than a half. That means we are looking at the upper tail. If it was less than a half, we would be looking at the lower tail. So we're looking at 8 up to particular number. So we're looking at this here. This is my upper tail, and the lower tail would be on the left hand side. Now there's 2 ways to approach this. We know how many times heads comes up, so that's one way. We can simply work out the probability of head coming up 6 times as they question or more, and work out if this probability that we get as a result of this is less than the 5% significance level, or we can find out the critical region, which is the second approach. We'll look at both approaches. So in the first instance, I'm going to work with the number 6 because it told us in the question that heads comes up 6 times. So what I'm going to do here is I'm going to find out what the probability of x greater than or equal to 6 is. Now, remember, our calculator has the function binomial CD, cumulative, so it goes from 0 up to and including a number. So the calculator does the calculations which are on the left-hand side, the lower tail calculations always. So this is the calculator. And if we do use our tables, the tables also use the left-hand side. So in order to work out the right-hand side, which is what we're after, we're going to need to work out what the probability of x less than or equal to 5 is. And once we do that, we can then do 1 minus probability of x less than or equal to 5 to work out the probability of x greater than or equal to 6. So let me write that down. 1 minus probability of x less than or equal to 5. So let's go and work out what the probability of x less than or equal to 5 is. We go to our binomial CD function on our calculator, and we have the option to put in x, n, the number of trials, and p, the probability of success. So x, the number of times head comes up that we're using here is 5. Okay, so that's because we're working out x less than or equal to 5. And the number of trials that we're doing is 8, and probability of success is a half. Typing this into our calculator, 5 for x, 8 for n, and a half for p gives us a probability value of 0.8555. So we can write down here probability of x less than or equal to 5 is equal to 0.8555 to 4 decimal places. So now we can go and work out what probability of x greater than or equal to 6 is. It's 1 minus 0.8555, and that gets us 0.1445. We can now write this as a percentage, 14.5%, and we can see here that this 14.5% is greater than our 5% significant level. Therefore, we have insufficient evidence to reject H0. So we can then conclude the coin is not biased towards heads. Now, suppose we wanted to find out how many times heads would actually have to come up in order for us to reject the null hypothesis, i.e. we want to find out what the critical region is. That's the second approach that we could take to do this calculation. So next, we're going to look at the same question using the critical region approach. So the test statistic, the null hypothesis, and alternative hypothesis remains the same. We're going to write down then what are the possible outcomes for x, i.e. how many times head could potentially come up. 0 all the way up to and including 8. So we're going to now take a look at the critical region approach. So first of all, we'll write down how many times heads could come up. It could come up from 0 all the way up to and including 8 times. And here, we're not really interested in that it appears 6 times. We want to work out the critical region. So we want to work out for the upper tail, what value would we need for our probability value then to be less than the 5% significance level. So I'm going to just split it up into the upper tail here, and I'll call this value here Z, and then I'm going to call the value up to here, I'll call this Y. Now remember, our calculator, which does the binomial CD and the tables, only does the left-hand side calculations, as it's cumulative. It goes up to and including from the 0 value. So we would need to do the left-hand side calculations and then do 1 minus it to work out the upper tail. So here what we're trying to work out is what value. So we want probability of x being greater than or equal to z, and we want this probability to be less than the 5% significant level. So if we want this to be less than the 5% significant level, then what we want on the left-hand side calculation, we want the probability of x being less than or equal to y to be greater than 95% or 0.95 as a decimal. Okay, so let's work with the left-hand side since that's what our calculator does. So for our calculator, we go to the binomial CD function, or we could use the table. We'll go to the calculator here, and the inputs that we can write down is what we can write down for x. N is the number of trials, which is 8. And P is the probability of success, which is a half, probability of getting ahead. And we're going to try different values until our probability becomes greater than 95% or 0.95. So firstly, I'm going to try an x value. For x, I'm going to try, so let's say, suppose I'm going to try 6 here. Okay, so I'll try probability of x being less than or equal to 6, and we'll see what that gets us. So that means I will be using 6 for my value on the calculator. So I go to my calculator, put in my value here, 6 for x, n is equal to 8, p is equal to 0.5, and this straight away gives me 0.9648. And we can see that this is greater than the 95%, which is brilliant. But could we have got that with x is less than or equal to 5? Well, let's just check. So we do the same thing again, but this time with x equals to 5, and this gives us 0.8555. So we can see that this doesn't give us a probability which is greater than 95% or 0.95, whereas this does. So we know here that x equals to 6 can be used for the y value here. Okay, so I'm going to go in, this is the one that works. I'll go and put that here. This value of y is 6. If that value of y is 6, then the value of z here must be 7. Okay, since we've got discrete random variables here. It's either 6 outcome or 7 outcome that appears as heads. So we can then go and say that if the probability of x less than or equal to 6 is equal to 0.9648, we can then go and say that the probability of x greater than or equal to 7 is equal to 1 minus 0.9648. And this gives us 0.0352, which we can see here is less than the 5% significant level. Okay, so this is our first value within the critical region, i.e. our critical value. So what is our critical region? Critical region is x greater than or equal to 7. Okay, so 7 and 8 are our critical region values. And what is the critical value? Well, critical value is the first number in the critical region. So 7 would be our critical value. We can then go and compare this to how many times 6 does actually appear. In the question, it says head comes up 6 times. So we can then write down head comes up 6 times in the test. Therefore, not in the critical region. So we can make the same conclusion: insufficient evidence to reject the null hypothesis. Insufficient evidence to reject H0. Therefore, coin is not biased towards heads. So we looked at two approaches here. We looked at the approach of using critical region. So this was critical region. And we also looked at the approach of finding out the p-value and comparing it to the significant level, which was this approach here.